Welcome to MirrorFly, a unified communications product for real-time chat, audio, and video calls SDK. I shall be walking you through integrating calls in 20 minutes. Let us deep dive to see how to integrate our calls SDK for the iOS platform. You may also use our sample application available in GitHub. Download today to explore more about the real-time chat and call features. This is the fastest way to build your app's UI with MirrorFly Calls SDK. You should also be aware of some of the basic requirements before you start working on the iOS call integrations. Before moving into the calls integration part, you need to know about the SDK license key to initiate calls. For first-time users, you need to complete the registration process to have a user account. Being a registered user, you get access to the unique license key and API credentials. Since I'm already a registered user, I'm logging into my user account. In the overview page, you could find your unique SDK license key. You can also get access to the sample project source code, SDK files, and API credentials in the same overview page to test your integrations. Let's start with integrating the calls SDK. In the first step, let us complete the pod setup. If you have not initiated any pods project before, then you would need to initiate it by opening terminal and by executing pod init command. To set the path right, you may copy, drag, and drop the project folder. After adding the project folder directory, run pod init command. Once you have successfully completed, open pod file. Now add the required pods that are necessary for the SDK to execute the process perfectly. Moving on to step 2 in pod install. Copy the hook code and paste it in the pod terminal to complete pod setup. The copied hook code to be added at the end of the pod file. Then run pod install command. So now the pod is successfully installed. Moving on to step 3 in the integration process. Open the XC workspace and open project settings and add a few more options to initiate the call. Now you have to disable the bit codes for your project. In the project, under the build setting, you can search for bitcode, and this has to be disabled. It is safe to turn it off now. We have added a few libraries in the SDK, and to get these compiled, bitcode has to be turned off in the project. Moving on to step 4 in the integration process. We need to enable a few more capabilities in your project. Go to Target, open Signing Capabilities, and click at the top left corner to search for the background modes. In the background mode, and enable the following modes: audio, AirPlay, picture, and in-picture. Then enable voice over IP and background fetch. With this mode enabled and your audio session configured, your app is ready to play background audio. Background fetch that allows an app to fetch new data or perform other tasks in the background when the app is not actively being used. In step 5, enable audio and video recording permissions. Go to the info file to add the camera and microphone permissions into information property list files. The info.plist file contains critical information about the configuration of an iOS mobile app, which the operating system uses to interact with the app. This file is automatically created when the mobile app is compiled. Add microphone usage and camera usage in plist for asking permission to use it in application. It's mandatory to add a description without fail, or else the call will not initiate. Moving on to configuring the server details in the calls SDK. Copy the server data in SDK. Access the data globally using the app delegate class. Import the MirrorFly SDK in app delegate class. You can copy the unique license key from the MirrorFly console overview page and paste it under the license key. We're using Container ID for remote push notifications. When setting up push notifications for your app, the bundle identifier is part of the configuration process. This allows push notifications to be sent specifically to your app. We'll discuss more in detail in the upcoming videos on push notifications. Now, let's initialize data for calls. We utilize the usage of the Initialize SDK function to validate the license key and to fetch critical data from server for SDK initialization. You must use the app delegate class within the did finish launching with options method, call the initialization method by passing the license key. Now, moving on to user registration. We shall register a new user using this method. It will take care of both sandbox mode registration as well as live mode registration based on the license key provided in the Call SDK. In button action, initialize the register method. When the register button is clicked, action will execute on it. While registration, the below register method will accept the additional params. User ID is a string or number we use to register or uniquely identify. Special characters in user ID are not allowed. Here I'm using the phone number as the unique identifier. Unless you logged out of a session, make sure that you have called the registration method only once in an application. During the registration, Register API Service method will accept the additional parameters that is required for notification processing on the server, such as the Apple Push Notification Service Device Token, VoIP Device Token. You can enable and use is Force Register as an optional param for maintaining sessions, User Type as an optional param to provide the type of user, and Metadata as an optional param to provide metadata of the user in Register API Service. Appends is used to send and receive push notification alerts, as said earlier. If you are using the call feature, then you would enable VoIP Device Token. You also need to attach the certificates to enable these alert services. Appends and VoIP certificates needs to be added to your server configuration section in the user console to enable push notifications. Now copy the register method. Paste it in button action. Call the user identifier in register method. Now let us connect to the call server. Once registration was successful, Call SDK automatically attempts to connect to the call server. The connection status can be observed and tracked by confirming the connection event delegate below following method. You need to set delegate in your view controller's view did appear. Using our extension view controller, we can set the connection event delegate. Once the connection event delegate has been set, you will be able to receive the connection status in the delegate method. Also, you have print the statement for connections. Once registration is successful, delegate calls the connection status, otherwise shows the disconnect status. Let's see how to initialize Call SDK. After successful registration, initialize the Calls SDK method in connection event delegate. Once connected to the server, it successfully initializes the Calls SDK. Let's see how to observe call events. To observe call events, create and set a single in class that conforms to the Call Manager delegate of Fly Call framework and pass that object to the following method. Using our extension, View Controller, we can set the Call Manager delegate. Once the delegate has been set, we will be able to receive the incoming message in the method mentioned below. Message Events Delegate Protocol has 11 delegate methods for call events. First, we have to set the instantiated View Controller object. To set the call UI that has to be presented during an outgoing call, call the Call Manager.setCallViewController controller method. An instantiated View Controller object has to be passed in the method. In Call Manager.setCallViewController controller method, add View Controller which we need to present once call function gets success. I already created the UI for incoming and outgoing call in Storyboard. Gives the outlet action in Call View Controller. Let's move to presenting the call UI. Call SDK handles the UI presentation for an outgoing call. Call the following method after declaring the Call SDK and/or before making a call. Call UI method is optional, else the Call SDK will present the UI for an outgoing call in the project's root view controller. Let's see how to make a voice call. Copy the code. Import the MirrorFly SDK. In button action, initialize the make voice call method. When make call button clicked, action will execute on it. Already created the make call UI in storyboard. Gives the outlet action make call view controller. User JID represents JID of another registered user. Once make a call initiated successfully, print the success statement, otherwise it shows the error. To make and receive a voice or video call, microphone and camera usage permissions were required. Calls SDK also provides a method to check those permissions, like call manager is audio call permissions granted and call manager is video call permissions granted. We can also make use of these methods to validate whether the usage permissions are granted or not. I implement the method in view did load. We can get a response in the completion handler, whether get connection is successful or not. End the call, you implemented the call manager.disconnect. In button action initialize the end call method. When end button clicked, action will execute on it. Let's see how to transfer initial call payload. Since we are making use of chat server to transfer initial call payload from caller to Kali. Once the above make call function was processed successfully, the following delegate method of call manager delegate will be triggered. There we can make use of the chat SDK method to send the initial calling payload to the Kali. Then call the function init call SDK in connection event delegate. Once connected successfully, init call SDK will execute and navigate. Now run the app on an simulator or a plugged-in device. Let's see simple demo for making a call to receiver side. First, you need to register and log in the user. I make a call to the receiver side. Call initiated. Wow, successfully connected both the side. Now make a call for sender side. Successfully received the call for sender side also. Once the sender answer the call, connection will connected both the side. Once the sender disconnects the call, the connection will be disconnected. Great. Hope this video is helpful for you in your MirrorFly call SDK integrations. MirrorFly is the best platform to build in-app calls in your application. Check out our documentation page for more such tutorials that would ease your integration setup. We have a dedicated customer success team to assist you with your questions and help you pass through the blockers with ease. Thank you, and have a good day.